Okay guys, so these are solutions. I'm starting with question 2 of the questions that I posted. So question 2, okay, which says a 5 kg ball falls into a box of sand from a height of 15 meters above the sand. If comes to rest at 4.0 centimeters beneath the surface of the sand, how large is the average force exerted on the ball by the sand? Okay, so guys, the best way to solve physics questions is picturing them. Picture it, put it on paper. So they are saying a 5 kg ball. So 5 kg ball, okay, falls into a box. Okay, so this is our box right here. Okay, the box of sand from a height of 15 meters. So let's say our sand is ending here. Okay, from a height of 15 meters. So this is our ball here. Okay, so it falls into a box of sand from a height of 15 meters. Okay, it comes to rest at 4.0 centimeters beneath the sand. So they are saying it comes to rest 4 points. So comes to rest 4 centimeters beneath the sand. Okay, and they are asking us to find the average force exerted by the ball, exerted on the ball by the sand. So yeah, we have to, okay, so we shall say we've been given we have been given the mass. They're saying it's 5 kg, so the mass is 5 kg. We've been given the height from where the ball is falling from to the surface of the sand is 15 meters. So for us to get the total height to where the ball rests, we have to get this 15 meters and add the 4 centimeters which is beneath the sand. So we know 4 centimeters is the same as 0.04 meters. So our total height is equals to, that's 15 plus 0.04 meters. Okay, so and then what else have we been given? Okay, I think basically that. Okay, so this solving such questions, so shall we use the principle of conservation of energy. We know that the change in KE, kinetic energy, is equals plus the change in potential energy plus the change in thermal energy is equals to 0. Those who missed their class, like thermal energy, examples of thermal energy is friction force, like okay, the work done by the friction force. Okay, so yeah, it's what we call that heat energy, like between two surfaces. Yeah, basically thermal energy. Okay, so shall say change in kinetic energy, change in potential energy, change in thermal energy is equals to 0. But let's say we know that this ball at the moment is at rest after it landed, and its velocity is 0 meters per second. So we'll get rid of the change in kinetic energy. Okay, because the ball doesn't have kinetic energy at this point. So we shall say change in PE is plus change in TE is equals to 0. So we shall say mg height final minus initial height plus F times S. This is the work done by the frictional force, which is the which is equals to 0. Okay, then okay, we know our final height since the ball is landed like it's 0. That's our final height is 0, so we only have minus initial height here. So when we multiply this minus initial height with what's outside here, we shall get negative mgh plus f times h, which is equals to 0. So when we take this other side, the other side, we shall remain with friction force times distance, which is the same as fs is equals to mgh. So let's make friction force the subject of the formula. So F is equals to mg over s. So friction force is equals to we know the mass is 5 kg times g, which is acceleration due to gravity, 9.8, times the height. Okay, so we have to get the total everything, like this 15 meters plus this 4 centimeters when we convert it to meters, which is 0.04 meters. So we add 15 and 0.04 meters, we shall get 15.04 over the displacement they're talking about here is like after the ball hit the sand, we need this distance which it covered after hitting the sand, which is 4 centimeters or 0.04 meters, is the displacement they're talking about. So we shall have 0.04. So when you multiply everything on top divided by what's down, your answer will be 424 newtons. Okay, so this is how you calculate, you apply the principle of conservation of energy in terms of a falling object. Okay.